Good morning, everyone, and thank you very much for joining us for today's webinar, Collaborative Action to Address the Climate Crisis Through Design. My name is Shalika Sivathasan, and I am the Administrative Assistant in the Continuing Education Department at the OAA. We will begin today's webinar by acknowledging the land on which we are meeting and calling in from. For millennia, the place we call Ontario has been inhabited by Indigenous peoples and nations who have been stewards of the land and who are deeply connected to its rich cultural and natural landscape. We would like to invite you in a moment of reflection to acknowledge our shared responsibility to address past and present injustices and provide space for Indigenous knowledge and worldviews to shape the architectural landscape of Turtle Island. Before we begin, I would like to share some important information to ensure an effective and professional webinar experience. Please be informed that this session is being recorded for quality and educational purposes. For accessibility, we provide automated closed captioning service available in multiple languages to accommodate the needs of our diverse audience. In order to maintain a stable internet connection, we have muted all participant microphones and disabled video feeds. Kindly note the chat function has also been deactivated. However, we do highly encourage engagement through our Q&A window, which you will find at the bottom of your screen. Feel free to submit any questions you have for our speaker there. Questions will be addressed during the designated question and answer period at the end of the presentation. For those seeking continuing education learning hours, please note that attendance is crucial. A minimum of 80% attendance is required for these hours to be accredited to your OAA transcript. Please just allow a few weeks for the processing and reporting of these hours. And lastly, please note that the presenter does not provide insurance, legal, or practice advice, and the OAA does not bear responsibility for errors or omissions in discussions during the webinar. Now, I'm very excited to introduce our speaker for today's session, Alex Lukachko. Welcome, Alex.
Hey, good morning. I'm pretty excited to be here to talk to everyone about this topic, and I think we've got about an hour, and there'll be plenty of time for questions and comments afterward. But for that first bit, I'm going to do my best to pack in as much exciting information as I possibly can, because this is a pretty important topic. But before we get rolling, this is going to be a presentation about collaborative action to address the climate crisis through design. This is something that I think the OAA and the membership, our profession in general, has been working on for decades, but as we all know, this crisis continues, so the pressure is ramping up. So we're going to talk about how we can do more together. My background, I'm trained as an architect. I went to the University of Waterloo. I spent 20 years working in parallel to architecture in the building science and sustainability field, before leaving consulting to start the Climate Design Initiative, which I'm a director of. That's a not-for-profit that is focused on, well, you might guess, collaborative action to address the climate crisis through design. I also teach at the Daniels Faculty of Architecture at U of T. So that's my background. Today, for this presentation, we've got some learning objectives that I think you saw posted. In general, we're going to be looking at, our responsibilities to create a resilient built environment and address this climate crisis to help serve society as a whole and the planet upon which we depend. But also, we're going to try and learn as much as possible about action that is happening right now between firms and across the industry, sort of outside of efforts that are going on at the individual level or even within practices, but working together to address some of these large challenges. And so I'll be giving lots of examples of that. In this presentation, I've got basically three parts. I'm going to start with some background and why we need collaborative action. I'll then give you those examples, and I'm going to center the examples around two different group efforts. One is the Toronto Circularity Network, and the other one is the Toronto BioBuild Collective. For those of you outside of the city of Toronto, don't worry too much about the Toronto title there. These are really big picture collaborative efforts. It's just that a lot of the collaboration needs to start locally, person to person. And these two efforts that I'm going to talk about started in Toronto. So that's why they have Toronto in their name. And then at the end, I want to talk about some next steps, because there are big challenges that we face as a profession, and there's a lot more work to do, and this will be ongoing. So that's the structure of the presentation. We got to start off with a conversation about the climate crisis. And I know that everyone on this call will be familiar with the climate crisis. I think maybe more so than many professions and the general public. Architects know a lot about this and have been learning a lot about it and are very engaged in efforts to change it. I just want to put the climate crisis into a kind of framework that will help with our discussion about action that we need to take. And I'm going to start with this, which is, I think, something that everyone is pretty familiar with. These kind of graphs show scenarios for future climate. This particular one is using data from climatedata.ca, which is a wonderful resource, if you don't already know about it, put together by the federal government to collect and publish all of the future climate data, the projections, the predictions that we have available to us. And as practitioners, this is amazing information that's been put together for us. But basically what it shows is historical data and future data. On the left-hand side, the gray, kind of up and down part is the climate that we've been used to in the past. And you can see that there's some variability there, but overall, a trend of temperature rising. And remember that mean temperature is just one indicator of climate change. We just tend to use that as a way of talking about how climate is changing, because mean temperature does drive a lot of other factors, but really we're talking about something more complex than just temperature rise. But there we see the variability for historical climate data. And on the right-hand side, we have those scenarios. The blue one on the bottom is the one that we hope to be on. That's the hopeful path. And really what that represents is a global effort to mitigate emissions, greenhouse gas and carbon emissions as quickly as possible. So that's the optimistic, hopeful one. The red one at the top is described as the business as usual one, and that's more likely the path that we're on right now. I say there in the note, that this is leading to a different world, and that's what the scientists from the Intergovernmental Panel on Climate Change talk about for that scenario, that the climate change shifts what we know so fully that it really is a different world, unlike the climate that we have in the past. And there are challenges with that business as usual path, not just global warming and the climate change that is related to that, but less certainty, more variability, less certainty along that path, because it really is something different than our experience in the past. So this is kind of like where our future is, somewhere in between those scenarios. And we've got a lot of information about it. In the short term, like where we are now, we're not going to know. We're going to see some differences, but we're not really going to be able to see the strong evidence of which path we're on, because in the short term, this all kind of looks the same. There's kind of a delay to these impacts that will only become apparent later. Now, importantly, if we're talking about building design, we build according to climate parameters that are put into the building code. And the bar that just popped up on the left-hand side there is a 30-year average climate that is what we use to establish our climate that we're designing for in different locations in Canada, using the building code as guidance. And it's sort of shifted into the past a little bit, because, as you know, we don't update building codes all the time, although the government has gone through, both at the provincial and federal level, has gone through a process of trying to update those climate parameters so that they're more like the future. But in all cases, the buildings that we've built in the past are built for a past climate, right? They're being built for a climate that doesn't exist anymore, no matter what scenario we are on in the future. And I think that's one out of this framework for talking about the impacts of adapting to a dynamic climate. That's like one key takeaway, is that all of our buildings were built for a climate that doesn't exist. as designers, if we were contemplating a new building or a major retrofit that would give the building like a 100-year lifespan, for instance, that's this bar that we're drawing on here, we'd have to make choices about what climate the building's going to be facing in the future. And these are really significant choices that I think we're still underestimating the importance of in our current practice. You'll note that no matter where you choose to draw this line towards the business as usual, the kind of worst case scenarios for future climate, or if we were to lower that towards the more optimistic ones, in either case, our buildings' lifespans are extending into a climate that is unlike the climate in the past. And so as designers, this is like a key thing that we have to be thinking about. And out of this framework, I think we can take away 3 imperatives for us as stewards of the built environment. The first one is we need to mitigate short-term emissions as quickly as possible. And we're, as a profession, actively engaged in that. We may not have the full support of the design and construction community and the people that we work for just yet, but we've been spending a lot of time on that first priority, reducing short-term emissions. We also have an imperative to reduce whole life cycle emissions, because those short-term emissions and the continuing emissions related to our built environment are really what are going to be driving what scenario we're on in the future. And so we really do have to be thinking about that whole lifespan. The faster we can reduce emissions, the more certainty there's going to be about what our future climate is, and the more likely it will remain in a kind of range that's more like the climate that we're used to in the past. And then the third one, I think, is maybe the most important one for our profession. We have to adapt to whatever future climate is out there. And I say it's the most important one because as stewards of the built environment, we have been given responsibility by our society to provide shelter no matter what climate we're building in. And I think this is, again, something that we should not be overlooking, that the whole life cycle thinking about design as it relates to the climate crisis is really core to our responsibility. So not only can we play a big role, but we're also, I think, obligated to be thinking about these things over the long term. Okay, this is background. I mean, I think we generally know what we have to do. I think anyone who's been involved in the OAA Con Ed cycles that relate to sustainability and the climate crisis will have received lots of information about this and is very likely thinking about it in practice. And we as a group know things like the built environment is a major part of our impact, maybe 40% of global emissions. I mean, that's not us in Ontario only, but we're contributors to the largest block of emissions. And because of our role in the design and construction industry, in the built environment more generally, we can do a lot to change that as designers. And I think that is something that the OAA, the RAIC, and the states, the AIA, and other associations have been emphasizing, is that architects do have a major role to play in leading change. And I think that this is a really important point when we start thinking about action that we can have as a group. And this is going to relate back to the rest of the conversation about collaborative action. And I just want to emphasize this last point again, that, yeah, we can lead change in reducing emissions for sure. We can sort of help point the path towards a lower carbon future. But no matter what happens and what kind of collaboration and cooperation we can get at the global level, we are always going to have that responsibility to provide shelter no matter what the future brings. And so we have to be thinking about that as a major thing. Okay, so we know what to do, but there are all sorts of challenges that we share as professionals. And I have a feeling that as I go through this list, there's going to be a bunch of nodding heads saying, yeah, that's something that I experience in practice as well. This is maybe the biggest one. Our industry is very project focused, and in most practices, there's very little time for anything other than executing the job that we're supposed to do. That's the imperative. And it doesn't matter how much we know about what the future needs from us or what society needs from us. We have to accomplish this first. That's a major challenge. We also have in the background, assuming that we have the skills, the resources, we know what to do, we might not be able to act until our clients are ready for us to do that. And I think many practices, individuals certainly, but practices as maybe a larger unit are in this zone where they have the expertise to design for the future, but are kind of limited by what their clients are wanting to do, wanting to pay for. That's a major challenge for us as well. We often depend on regulation to be that thing that uplifts everything as we go forward. But regulatory change is very slow, and for anyone engaged in sustainable design or low carbon design, you'll know that there's a back and forth process with that. And at this moment, depending on regulatory change seems to not be a solid short-term answer. But we still have to, we work in a regulated environment, and we kind of have to wait for that as well. So that's a challenge. Individually, we might be unsure of how to tackle some of these large problems. We have a job to do. We certainly have a broad scope in terms of what we're able to influence in terms of decision making. But all of these climate-related problems are larger than the area that we're building in. They're larger than the building or city or region even, and interconnected with other parts of our society and the natural world around us. These are very large problems. And I think if you add all of that up, you may be feeling like you're in this position of being unsure about what impact you can have either alone or as an individual practice. Okay, so these are challenges, but I think they point directly to collaborative action as a response. We really can't overcome these challenges alone. And I do see a lot of firms in my work consulting with different architecture firms at the level of their practice and their practice's response to the climate crisis. I see a lot of firms making individual efforts, strong individual efforts, but tackling problems that are probably going to need to be tackled together, right, in order to make that happen. And especially when we think about how much learning and change we need to accomplish in a very short period of time. And I don't think I'm saying anything that people would not be familiar with. We're in a very conservative industry, maybe rightfully so. Providing shelter for our society is something that we can't fail at. And so even the most frustrating parts of our industry are probably doing what they should be doing in being cautious about change. But at this moment, to address the climate crisis, we have to be moving things forward faster. And that's probably something that we also need collaborative action to help make happen. And then I'm going to say this too, even though this is an OAA sponsored webinar, I'm going to suggest that our professional structures, and this doesn't have to be a comment about the OAA, you could think about this about our, the profession of architecture more generally, and at different levels of how it interlocks with different levels of government. Our professional structure wasn't really designed for rapid and widespread change, and the organizations that support our practices are not, even though they do quite a bit, are not built around the mandate of influencing beyond the scope of what we're charged to do as a practice. And so we're kind of, needing to do something more than what we have in terms of a professional structure or in kind of the business as usual change in order to accomplish these goals of overcoming these challenges and doing so very rapidly. Okay, so that's why I think collaborative action is something that we need to be focusing on. So for the rest of this presentation, I'm just going to take one challenge that is facing our industry and give you some examples of collaborative action to address that. So embodied emissions or upfront greenhouse gas emissions associated with the materials that we use to build is increasingly on the radar of design firms. And I think there's a growing understanding, certainly in the last 5 or 10 years, a major shift in understanding that this is something that we need to tackle directly because it's a big challenge. And there are all sorts of sub challenges or issues that come out of that make it one of these big ones. So you've probably seen information like this. This one's coming from the Architecture 2030. and looking at a high level, thinking about business as usual projections going forward and what carbon emissions might look like from 2020 to 2050. So just really the next 30 years or so. Embodied carbon and operational carbon, the upfront piece and the ongoing piece, are about equal in terms of, are expected to be about equal in terms of where those carbon emissions are. So it's pretty key that embodied environmental impact is something that we really need to be focusing on. Okay, so we're becoming aware of that. If we were to redraw this graph a little bit, let's go right up to 100% and then change this, instead of total emissions, to say where we should be putting our design effort. I think it becomes even more lopsided here. I think that on the operational carbon side, in terms of where we're putting our design effort over the next 30 years, it's going to be something more like 15%. It's going to be a relatively minor piece. The reason for that, and just very brief, is that we've been working on the embodied energy and the emissions therefore related to that energy use for 50 years. We have a long history, and there's a Canadian connection here as well. 1975, the very first energy conservation codes were introduced into North America, and that was at the middle of the oil cost crisis. That was a global phenomenon. So there's a strong response in the design of the built environment to minimize the amount of energy use in buildings. And so we have examples like the 1977 Saskatchewan Conservation House, heavily insulated, airtight, using renewable energy wherever possible, heat recovery from ventilation, all of the kind of the pieces of the recipe for an energy efficient cold climate building prototyped 50 years ago. And I would just skip forward to this building at the University of Toronto Scarborough campus, which is a passive house residence building designed to the passive house standard, a direct linear path in development from prototypes to fully functional large-scale buildings with a massive reduction, like 80% reduction in the amount of energy used. And this is just to say, like, we've accomplished a lot on this particular topic. The thing that's been added to both the energy conservation movement and passive house is we've been concerned more about the carbon content of the energy that we're using. And Ontario still has one of the cleaner grids in North America and is projected to at least be in the neighborhood of that over the next 20 or 30 years as well. And so we know that to solve the operational carbon side, we do these measures on the right-hand side, and then also add low carbon electricity, probably is the way of driving our buildings. This is just to say, this is more or less a solved problem. We know what that recipe is. Most of the work is going to be on the embodied carbon side. So in terms of our design effort, that's where we're going to be spending most of our time. And I think it's doubly important, not just because that's 50% of the carbon over the next 30 years that's not well addressed with our current code standards and best practice around sustainable low carbon construction, but also because the materials have a direct relationship to the architecture, how we build and what it looks like, how we use those materials and turn it into new buildings. I'll give you one example from a fairly well-known architecture firm internationally that is a pointer to what future buildings are going to look like, what the architecture is going to be like when both the operational and the embodied side are taken extremely seriously. So this is an office building for a client that is very invested in sustainability. So it's a prototype, and they went to extremes, but it represents effectively a teardown of what an office building is, and then building up using low carbon materials and designing for a low carbon operational threshold. This is the kind of building that we're going to need. You can look up more details about this project. I would just want to point out a couple things, that it's like, as an architecture, not like the office buildings that we've built for the last 100 years, right? This is a different pathway. There's some other really fun things here. Like, you can see the mass timber. You may not be able to see, if you look at the ceilings through the glass here, clearly that these are small vaults of rammed earth planks that are added to mass timber construction The whole building structure has been reimagined. The facade looks different. You may notice down at the courtyard level, if you look closely, that this whole building is actually lifted off the ground. So that courtyard level is continuous with grade inside and outside the building at the perimeter to minimize the foundation. So this whole lightweight mass timber structure is built on piers. Pretty amazing. Lots of work went into this. And, the results are that you have an environment built out of almost entirely biogenic, low carbon materials. And as I said earlier, approaching a new architecture in order to achieve this. That's where we kind of need to go, right? Not just incremental improvements anymore, not just a focus on operational energy, but more holistically thinking about the building and particularly what we're building out of. I ran a course at U of T for the last couple of years that has looked at how practices have been responding to the climate crisis. And so I wanted to offer you a little bit of a survey on where we are right now in practice. This course had a pretty direct title, How the Climate Crisis is Changing Architectural Practice. And over 2 years, we visited 9 different firms, all in the Toronto area, because this was a University of Toronto course. So we would go to each one of these firms on each week of the course. And we were able to visit most of these 2 years in a row. In the first year, we asked, what does sustainability mean to your firm? And then how do you do sustainability? Like, how is your practice actually changing to do sustainable design? This past year, we asked more directly, how is the climate crisis changing your practice? And from these 9 different firms, I can tell you we got 9 very different answers, all very interesting and in-depth responses that really came out of that interesting mix around practice of the clients, the people that are engaged in the firm, and then as a group, like what the direction of the firm is, what it really does, a unique characteristic of the practice itself. Very informative, but here's some observations thinking about this mix between operational carbon and embodied carbon, and that the direction that we need to go in. I can say that of the 9 firms that we visited, all of the firms were discussing energy use intensity. So they were all thinking about the operational energy of the building. About half the firms tracked energy use intensity for every single project that they worked on. So I would say that that's a pretty strong investment in thinking about the operational carbon of the buildings. We did hear that most of the firms, the work was driven, like the work on low carbon architecture was driven primarily by the client's objectives and expectations. There were a few firms that said, look, no, we do low carbon design regardless, and we have ways to do it, but on the balance, this was still being pushed by clients. All of the firms discussed the importance of embodied carbon, but none of them actually did life cycle assessments to measure the upfront carbon on every single one of their projects. And maybe that's a high bar, but remember, this is like 50% of the work we need to do going forward. And so our expectation should actually be high as well. But almost half of the firms actually did life cycle assessments in-house and had that capacity. And I can tell you, as someone who's been involved in teaching new generations of architects for couple decades, all the young people know how to do life cycle assessments. So this should change pretty rapidly. There's a large amount of awareness about how this is going. A couple of the firms had actually done not just life cycle assessments in-house to measure those upfront carbon emissions, but also enhanced scope, meaning that they thought more than just the required core and shell in order to achieve compliance with current standards around embodied carbon, but really thinking about everything in the building. Like, let's include mechanical systems, let's include interiors, let's think longer, like maybe the whole life of the building, maybe include landscape, maybe even think about transportation carbon that's associated with decisions like, where do we put this building? Like, we have a choice of sites. There are carbon implications according to that as well. So I thought that was a positive thing that firms were moving in this direction. And almost all the firms were doing materials research of some sort. And so this is like starting to get deeper on the challenge of embodied carbon, not just can we minimize it with the materials we have, but what are our alternatives for materials? And this seemed to be a common challenge. But at the moment, most firms are sort of doing this material substitution, which is the way, by the way, that we've been doing energy improvements with buildings, starting by thinking about things like we have no insulation, can we have insulation? We have poor performing insulation, can we have better performing insulation? We have double glazed windows, can we have triple glazed windows? Just like specifications changes that don't affect the design as much. It's not until you get to really deep energy or carbon savings where you start getting whole building requirements that really change the architecture. I think when we're talking about the materials, most firms we're still just thinking about that material substitution, and the tools we use kind of encourage that. That being said, there's like in the Toronto area, lots of examples of buildings that are pushing down the low carbon side. I would say these are all wonderful buildings that everyone should know about. But they also could go much further if we get outside of that core and shell approach, like structure and building enclosure, reducing those emissions, but instead thinking about the building more holistically. We could do a lot more. So practices were all engaged. I guess they were all engaged, but slow to change, mostly changing based on clients' needs and interest, and still having to do a lot of research, a lot of gaining of knowledge in order to go further. Okay, so where do you go past this? Where do you go past this? I'm going to talk about two collaborative action projects that many of the firms, by the way, that I just talked about in that survey are involved in, but happen outside of the firm. And so both of these examples have some common characteristics that I think are kind of important. I mentioned already that this kind of sharing of information, I think, works best with local networks. So that this is one characteristic, that there are people that know each other or can get to know each other and form a supportive relationship with each other. That's important. Both of these efforts that I'm going to talk about are led by young professionals and supported by the more experienced professionals. I think this is something we need to really be playing on. I see people coming out of university knowing what they need to do to change the world with architecture, but entering the profession in a way where they're not going to be able to learn about those ideas or learn how to apply those ideas for maybe decades. And they need help. They need guidance and they need support to make that happen, but they know what to do and they have the energy and time. The experienced professionals don't have the time, but they've got all the other resources to make this happen. So setting up local networks that are led by young professionals, but supported by experienced professionals, that's a pretty good recipe right there. These networks have both started with the design and construction industry, mostly because we have that responsibility for affecting the design of the built environment, and also because architects in particular have the ability to influence the decision-making of dozens, if not hundreds of people downstream from design, and also regularly make value propositions to people who are upstream, buying buildings, financing buildings. And so we are deliberately in a position where we have that kind of influence. And so using these networks, we work through each one of these two examples. I'm going to give you, works through the same idea that the first step is to engage as many people as possible and keep that process of engaging more and more, starting with the design and construction industry and then going broader, having enough discussion and conversation to align that group around some next steps, and then to build momentum from piece to piece. So this is not about having a conference, bringing people together, sharing information, everyone feels like they've learned a lot and then go back to their desk. This is about creating something that will continue to grow in support and influence. And that's really, all of these characteristics are super important. And they lead to effectively no-fail efforts. All the time that's invested at a voluntary basis or put in by the firms or other experienced professionals who are contributing, are all at a minimum benefiting from that engagement with others and learning and the knowledge sharing and alignment around key issues, and the action that the groups take are at least establishing learning and experience in a positive direction. So this is what we're aiming for. So here we go. The first one that we're going to talk about is the Toronto Circularity Network. And before I dive into this one, I think we've got an opportunity to do an intake poll related to circularity. And so I want to hear, or want to show, I think, the group as a whole a little bit about where we're starting from. And so here's a question for you. Do you consider these things in design right now? And so you can choose as many of these options as you like. I've set these up as statements that you can agree with and select or skip. The first one, it's a simple ask. I'm designing a building for a particular length of time. This is fundamental to thinking about the future. Is this a 30-year building? Is this an 80-year building? Is this a 200-year building? Do we think about how they might be taken apart as they're modified or dismantled? Do we think about materials that have the potential for reuse after the first use in the building that we're designing? And then maybe how do we handle existing buildings? If we're taking them down, do we think about an audit to find out what kind of information or what kind of materials can be used in other buildings? These are all kind of fundamental things. So I'm kind of curious, for the 100 or so people that are on the call, how much of this are we doing right now? I think that's been almost a minute of time to submit some answers. So why don't we have a look and see what the results show? All right. So we can say that a few people are designing buildings to be taken apart. 2/3 of the people are thinking about a particular service life. That's critical. So this is really good. I also think it's fantastic that half the people on this call are thinking about materials that have the potential for future reuse, especially now where we're using so many low-cost materials that are hybrids of materials that are, first of all, not designed for long life, but also very difficult to take apart and reuse, either at the component level or at the material level. So this preference is a good one. And then it looks like there's a growing use of deconstruction audit. So, okay, fantastic. This is good. So this is where we're starting from. And these are the kind of considerations that many people in the design and construction industry in the Toronto area had. So the Toronto Circularity Network started basically as just like a way of compiling this interest and information around deconstruction. With a fairly simple organizing principle. We're a whole bunch of people interested in advancing the emergence of the circular economy in Toronto's design and construction and reconstruction industry. That's the mission. So this group started 3 years ago doing monthly meetings, just slowly pulling in more and more people. It started with primarily professionals on the architecture side, and folks at the universities, both U of T downtown and Toronto Metropolitan University, and then very quickly grew over time into other zones. We encountered other circles of people, for instance, engaged in circularity around materials where there might be some overlap, like interior materials and finishes, a whole group of people that were already working in that area. Other groups of people that were more on the trade side, especially around deconstruction. And this network grew from being, just a few people to, I think there are 300 or 400 people on the mailing list, and a large amount of participation in events over time. And so this was like the starting point for engaging people and starting to create some alignment. Out of this kind of monthly discussion, a bunch of different ideas came up that were all acted upon by volunteers. One that we did 2 years ago was centered around the reuse of materials that we're currently specifying. And it literally came up in a conversation where 2 different architecture firms were saying, we got to clean out our materials library. And it's just so painful to do this. I know this is common to almost every single firm. You accumulate all of these material samples, and they're not actually useful for much. And at a certain point, you just have to get rid of them so that you can do this whole process again, because it occupies a lot of space. So we saw an opportunity. The group saw an opportunity to do this clean out, and at the same time have a conversation around what are the materials that we're specifying, because of course the samples are a problem because they take up space, but we're specifying millions of square meters of this material that is out there in the built environment, and it eventually is going to end up in this situation. So this was a really easy action that could be repeated in other places. We picked up all the stuff and brought it to one place and had a team, I think there were 30 or 40 people that basically sorted everything into piles of, here are the glass samples, here's the wood related things. And then material reuse experts talked to the group about each one of the piles. Some really interesting things were said, like there's a lot of frustration, like don't specify these hybrid materials because I can't do anything with them. Like after their one use, they can't be taken apart. There's no recycling. They can't be reused. They can only go into the dumpster. But other areas like wood-based products, for instance, much more flexibility. Not all wood is equal, but we learned a lot about those different pieces. So it was a really interesting exercise to dive deep into the materials that people are dealing with on a day-to-day basis. Some of it ended up in the dumpster. We're going to repeat this process again, by the way, in a year, and just get a sense of like how much waste diversion was actually accomplished the next time around, and where does the discussion go? And we'll probably expand it a little bit. SVN and Dialogue and KPMB were the three firms that brought, I think, I'm going to say 4 or 5 van loads of stuff to this first one. And so there's a lot of learning and sharing done there. By the way, we also engaged the Ontario College of Art and Design to like make other use of some of these material samples. And I don't have a picture of it, but there were a whole bunch of like handbags and other pieces of art functional art created out of all this. And all of this was in service of, raising awareness about the materials that we use, and then also starting to dive into the specifics of what can we do with these materials? How can we do what we're doing a lot better? A more recent idea that came out of this group was a deconstruction guide that was just recently completed, centered around this question, again, that came up just in conversation with the group. Do architects and homeowners know that deconstruction is even an option? Thinking about the circularity idea that we can reuse materials, one of the key things is just even making decisions at the right time about reusing rather than throwing material out. And the group thought that probably the answer was no, there's not enough information on the table. This guide was produced in, I think, 3 or 4 months, and there were several different working sessions where volunteers from the Circularity Network worked in groups to like tackle different questions and sort of decide what information needed to be in the guide, and then put it together in 2 packages. The first one is finished, that's meant to be for homeowners, and that's what you're seeing here, part of that guide. And there's another one that's for architects who would be working on primarily residential buildings to help them with understanding what can be done, and then also sort of laying out some value propositions as well. This is, I think, exciting, not because the information is necessarily new. In fact, there's a long history of deconstruction in our cities. You just have to go back 100 years to find it. It's more that all of this information was brought together by teams of people doing it because they thought it was needed. And, this was all volunteer effort, and I think done to a very high quality. What the group is doing right now, and by the way, something that any of you could help with if you're interested, is finishing the information for architects, but then also thinking about where does this go in terms of creating momentum? Who needs to have this? Like, should it be printed and pinned up on demolition sites? Should it be mailed to people? Should there be a social media campaign around this? There's a group of people in Toronto who are really interested in basically doing a YouTube series on like just showing people the value, the benefits, and the value of deconstruction. All super interesting things that are like little chances to make a difference, but as a collective can lead to quite a big impact. Okay, so there's one example of this underway, and again, the idea is that this is all based around work outside of individual firms, but giving a chance for people to pool resources and pool energy and really engage a much larger group of people to have pretty successful results. The second group that I want to talk about is the Toronto BioBuild Collective. And here's another opportunity for a poll as we get into this. And so I want to ask you, what do you think right now? Like, can biomaterials be used in large buildings? You've got some simple answers here. No, maybe someday. And yes, we can do it now. What do you think? There's a reason to ask this question. I think you probably know that we have a long history of using biomaterials in certainly small buildings. There are groups like the Ontario Natural Builders Coalition that for decades has been promoting, supporting the use of straw bale construction, hempcrete construction in areas primarily outside of the major urban centers, but have a huge sort of network of suppliers and trades and designers that are experienced in using biomaterials. So, you know, the answer is certainly yes to can we use it in buildings? But the question is, how about large buildings? How about extending this to even larger ones? Let's have a look at the poll and see what happens. Okay, so I'm very happy that only 4% said no, we can't. And you're not incorrect. If you were to ask this question in today's context, actually, it's very complicated to use biomaterials for any significant portion of all large buildings, for sure. I'm glad that there's a lot of optimism in the rest of the group here, because we're going to need this going forward to address this challenge of the embodied emissions and the upfront emissions in buildings. So the Toronto BioBuild Collective is another between practice effort, and it engaged initially. There were 4 firms that very quickly grew to the list that you see here on the screen, that included both architecture firms and universities and some consultants who were working in this space as well, pooling knowledge together. The group started in a slightly different trajectory, meeting monthly, but more focused on the needs of individual practices. And so I think this is a repeatable format as well that you could start in other areas, where each one of the firms basically got a 2-month cycle where they would have a small group meeting to discuss issues, then plan out an event that they would host at their firm. And it could be something about sharing information, and it could be something about, like maybe sharing something that their practice did, or maybe receiving information, and the group would go out and find either someone to run a workshop or contribute a lecture or something like that. On the screen here, you see Dennis, who's an architect in Toronto, very happy about receiving this display of biomaterials into his office, and he's just about to set up for his entire team, what you see on the right-hand photograph there, which was one of the first efforts that sort of came out of conversation, just thinking, what are the materials that we've, as a group, researched and know are basically ready to specify in buildings? And so what you see on the right-hand side are a range of enclosure, insulation, cladding, the kind of enclosure materials, and then also towards the further end of the table there, a whole bunch of interior finishes that these firms collectively had identified, I guess I should say individually had identified as something that they could deploy in their buildings right away, and had ongoing research to identify more. Well, simple thing, we just put them all together, and it was pretty amazing to see how much could actually be done right now with suppliers that these firms were already familiar with. And that led to a public display, by the way. It was set up in different architecture firms and then set up for the general public in a gallery in Toronto. I just want to say one thing about that exhibit, which was pretty fun. Like, other than seeing the range of materials that would be available for building that all had kind of like a bioregional connection and certainly lower upfront emissions associated with the extraction or manufacturing and transportation of these materials, there was also a lot of enthusiasm around like the actual sensory qualities of the materials themselves. I don't think I've ever been to an industry trade show where people have picked up and touched and smelled materials as much as they did in this gallery exhibit. It was a pretty interesting thing to see. And also, I think a good reinforcement of the idea that if we start choosing materials based on what's appropriate for human and environmental health, there's a natural affinity there that it strongly resonates with the people who are going to be living in and using our buildings. And that's like a really good starting place. So again, this list of firms was all doing research in this area independently, putting time towards that effort, but then collectively was able to almost immediately make big steps forward in knowledge. And that led to the last piece of this example that I want to talk about, which is this wall assembly mock-up project. So what we decided to do next as a step for the group was to explore the use of biomaterials from our bioregion, specifically in larger buildings, and to do it in a way that all of the firms could learn from each other and really think through challenges and opportunities, and then share this outside of the industry. So this was structured as a group effort, all volunteer contributions in 3 phases. The first one was research. Each one of the firms was charged with basically devising a wall assembly that would be suitable for their practice, like buildings that they work on in the future, that was made out of bio-based materials from our bioregion. Teams of volunteers then helped. The research phase was done. These wall assemblies were drawn out and materials selected. We're now in phase 2, where we're sourcing those materials and building mock-ups. They're 1 meter by 1 meter by 1 meter corners of buildings or sections of buildings, and then using all of the research and the mock-ups to create an exhibition that will be happening at TMU in the fall. In the summer. That was the structure of the project itself. There were 6 project teams. These are the firms. Each one of the firms had, as I said, a different wall assembly. I can give you some examples, and I'll talk through one in detail. B+H and KP&B both thought about healthcare buildings, different portions of the buildings. KP&B was thinking about like a patient tower, sort of a particular use. B+H was thinking about the sort of public podium spaces in a building, and that was where they were going to place their wall assembly. SVN, which is now WWP, and Studio Deep Plus thought about residential buildings in different ways. Studio Deep has a project that is current just outside of the Toronto area, in an area in a region that has a lot of agricultural activity, and they were very interested in making a connection between post-agricultural waste product, biomaterials connected with residential construction in that area. And so that's the basis of their wall design. SVN does a lot of future planning. And so their perspective was, we should be thinking about work in like 20 years from now, not just what's happening next year. Dialogue thought about higher ed buildings. MJMA thought about community buildings, like arenas, community centers, because that suits their practice. Both of them thought about, well, what could we do immediately? Like, what is the bio version of what we're building already that we could potentially implement on our current projects? So a range of different efforts, and each one of those architecture firms established the framework for the requirements for what they were after, but then we're supported by a team of volunteers. So 8 to 10 volunteers from the industry, some architects, some engineers, some students from the universities, worked with each one of those firms in the research phase. I'll dive a little bit deeper into KP&B's example here. So KP&B positioned this wall assembly project as part of a larger effort to design a mass timber hospital of the future. And so this was just a way of zooming in on that larger effort and thinking about, for patient rooms in that building, how they would build a fully bio version of that to go along with their mass timber structure. And so that fit in nicely with learning that the firm was doing already. And I'm just going to talk through a few of the things that they found. Here's their wall assembly that they ended up developing along with the research. This is the kind of thing that will be shared publicly at the exhibition phase of this project. You can see on the right-hand side the mass timber structure, the idea that there'll be a panelized mass timber, thin CLT backup wall with exterior insulation and cladding as the sort of basis of their wall design. The idea was to use exterior panels that were made of biochar, use exterior insulation made of wood fiber. You can see for each one of these, they've chosen particular suppliers out of what was available. The membranes were difficult, but they found actually drainage planes made of sugarcane, not available right now in North America, but something that has been made and could be used on buildings, could be purchased right now. Mass timber for the backup wall on the interior side. We're starting to get towards the specific requirements of hospitals for infectious disease control and cleaning and impact requirements. They thought about, although it's not a biomaterial, a much better lower embodied carbon approach, magnesium oxide board, and maybe a lime-based paint to the inside. That was kind of like their summary of the research. And overall, there was the key takeaway from that project was that there was a lot more, even with the high technical challenges, a lot more available for people to dive into right away. And although it's kind of future focused, their design really illuminated the possibilities. This research project, so that was one wall assembly of 6. That structure allowed for deeper work for each one of the firms to push their own research forward, but then also sharing between those 6 firms of the information gained. And then it also allowed a whole bunch of other participants to support the project. So Toronto Metropolitan University students did some hygrothermal analysis, thinking about heat and moisture for each one of those assemblies and doing some preliminary work on understanding whether they would work or not. Mantle Climate added guidance on design for disassembly. So comments for each one. Ellis Don's construction sciences folks talked about constructability review, and I think got the projects to a level of detail that we would not get to if we were just thinking about design. Builders, because it's more applied and really thinking about process. Builders for Climate Action provided a database of suppliers that they've been maintaining, also a guide for effective R-value calculation because that was a need on the project. Have Climate Design created a guidance document on how to research biomaterials. And so not only did they improve the projects, this collection of other participants, there's also a whole bunch of documents that will come out that we can share with the industry as a whole. So as I said, this project got to the preliminary phase, finishing the research. This is an image of one of the presentation boards, not that you can read in detail, but I think it gives you a sense of the kind of depth in analysis for each one of these projects. And this was all shared with the group of 60 or 70 people working on this project. And this will be shared in a different format with the design and construction community as a whole at Toronto Metropolitan University in the summer. Okay, so there's an example of tackling the embodied carbon thing in collaborative ways. 2 different groups. They're ongoing and creating kind of collaborative structures for addressing the climate challenges together. But there are other challenges that we have to do as well. There are some other initiatives that I think would be along the same lines. AdaptTO is a Toronto area network focusing on community level resilience and adaptation, not just buildings and infrastructure, but people as well, connecting that dialogue together. GRAIN is the Green Roof Agriculture Innovation Network, dealing with food security and also thinking about the climate impacts, very built environment connected. There's an effort that is going to eventually have a new title called it's currently they're referring to it as the new Stone Age, but thinking about structural stone use to offset carbon in our traditional structural materials. That's being used as well. And through these conversations, lots of other challenges came up that haven't been tackled yet, but could be through these collaborative networks. Things like we need to change our standard specifications towards buying local, decarbonizing. That's an effort that many firms are going down the path of, but would be done faster and probably better if we did it together. Low carbon assemblies for the enclosure and maybe for interior purposes as well. Lots of firms are doing research in this area, but this is something that can be shared and pushed forward. How to use materials like low carbon concrete, wood fiber insulation. These seem like obvious things that many buildings are going to use, but does every practice know enough about how to do that right away? And then other types of challenges, like how do we talk to clients? How do we talk to the general public about what we need to do? Those are things that can be worked on collaboratively as well. I'm sure that you can think of many more of these, and I would welcome all of your suggestions. If you were to suggest some, I would probably also ask you, what are the first steps that you can take to help push this forward? Because we're going to need that to get other people engaged as well. Okay, I'm going to wrap up because we're at our 60 minutes. But what I wanted to sort of show you in this like set of examples and the background information that I gave is the potential for moving faster by doing it together. And I think that this is what I would be asking all of you to look at as a way of addressing the climate crisis challenges as a profession, to engage in collaborative research and practice, build these kind of networks or contribute to them if you can. And like wherever possible, use that agency that you have as designers and pool that together outside of projects, outside of the constraints of your practice, because we're really going to need this to move forward. You can find information about both of these networks online if you wanted to know more. And I think I would leave it there because we want to leave enough time for questions and discussion if we go. So thank you very much for attending to 60 minutes of conversation about this. I hope that you're excited about some of these possibilities, and I hope that you've maybe got more challenges and opportunities to contribute to the collaborative discussion.
Great. Thank you so much, Alex. So we are going to shift into the Q&A portion of today's webinar, and we already have a few questions in the Q&A window, but if you do have a question for Alex, please submit that in the Q&A window below. You'll find it at the bottom of your screen. But I'll go ahead and start with the first question that we have here. So someone has asked, is the National Building Code of Canada working on setting minimum building life cycle standards and maximum embodied carbon standards that would significantly reduce carbon emissions for generations?
So I don't know everything that's happening on this topic, but I do know enough to say that the answer is yes, kind of, to both of those pieces. So there is a framework for life cycle standards. You may be aware of CSA standard S478, which is about durability in buildings that lays out a framework for thinking about what the design service life expectation should be for different building types. That was upgraded from guidance to a standard so that it's potentially something that could be referenced by the building code. But that's been around for decades. So that is there, even if people use it or not. It may not be literally part of the building code, but that information, that framework is available. And I think there are efforts to move that into the code. As I said, that would be a big lift, right? Because then we're asking everyone to think about that whole life cycle and to really address those adaptation challenges over the lifespan of a building. And then the maximum embodied carbon standards are much more complicated. There are voluntary standards like the CAGBC Zero Carbon Certification Program that does have thresholds for embodied carbon, mostly core and shell, like not measuring necessarily everything that goes into the building. and maybe not necessarily being very aggressive, but that's the starting point, is at least starting to measure and report on this. There's a lot we don't know about embodied carbon and a lot of variables. Like, it's hard to get the information still. We don't have a system of suppliers declaring their embodied carbon universally like they do in some places in Europe. That might be a building block that we need, just access to the information. And there are also variables about, how long do things actually last, and are we using the right framework for analysis? But those are starting to become available, and I know that there is a discussion around the Natural Building Code of Canada. So I think the answer is yes, kind of, to both of those things.
Right. Perfect. Thank you. We have a couple of questions around sort of getting more involved. So someone has asked if there are resources or opportunities to become involved, and another person has asked about whether there are sort of forum chats or places available where there could be more discussion on the topic.
Yeah, so I'm not 100% sure what the OAA has on their website. But I know that the OAA has committees that have been operating for years to gather interest on this. I think that might be useful, and certainly as an association, we would look to the OAA as one way of structuring those conversations. But I do think that there's a limit to what the professional associations can take on, and there's a lot of action that needs to happen. And so that's why I think I would put more of the emphasis on, are there chats or connections that can be made with you in your community, and like think more locally and build from there. And there's a good reason for that, not just in that it's going to be like faster and more direct to get that going, but also, you think about the embodied carbon issue, the answers, like what we're going to need, change from location to location as well. And so the best kind of knowledge that you can get is not likely the stuff that is freely available online or maybe even published by the associations at a provincial level, but locally, like, who are the suppliers that you could draw on? What are the capacities of the trades? What are the interests in the community in making connections with materials? Those answers are probably going to be a better foundation for moving forward, and they're only likely to be available if you sort of build those networks locally.
Mm. Great response. And sorry, also, if there's resources or places, opportunities to get involved, are there any that you know off the top of your head?
Yeah, well, I mean, there are these two. You could definitely join up with those. I think there's a whole list of other. I mean, probably a lot of people are familiar with other efforts that are out there, like the Canadian Green Building Council has local chapters. They're focused around voluntary certification systems, but more generally raising the bar in terms of knowledge around sustainable design and practice. So I think there you would find maybe good communities of people. The Carbon Leadership Forum would be another group. I mentioned earlier the Ontario Natural Builders Coalition. You're thinking about materials specifically. Although they've been working on smaller buildings than maybe some members are currently working on, there's deep knowledge there that you can support. So there are those groups available to connect with. But I think also we should not hesitate to make new ones. Like, I don't think there's any risk of like overlap or duplication, because there's just so much engagement that is required, and doing that kind of like local start, I think is going to be a big deal.
Great, thank you. So someone here has asked, has there been any engagements with the Ministry of Housing/building officials?
Well, not specifically that I know about, although I can speak to the Toronto Circularity Network and the Toronto BioBuild Collective because I've been involved in both of those organizations. We routinely get people from the City of Toronto attending those group sessions, including building officials. I'm not sure that the Ministry of Housing has participated directly in any of those conversations. There's certainly been outreach from these groups to talk to people in government and offer support, but not so much in a lobbying way. I think both groups have been sort of thinking about it as there are already good existing policies that need support. Like, Toronto, for instance, just released a circularity framework that deals with buildings as a major portion of Toronto's circular future. And the city of Toronto folks have spent a lot of time organizing all the city departments who were engaged in circularity around getting that alignment within the city. They need support on the external side. And so I think that's the kind of mode of engagement with the Ministry of Housing and building officials, is to understand what they're doing and help kind of create an environment outside of government that can support the regulations and policies that are there. It is true, I think, in almost every case that government has good ideas. They get moved forward when politicians support them, and politicians support them when there's, political capital to be gained. And so how do you build that? Well, you also have to work grassroots, bottom up, and there's a lot of space for agency in that area.
Right. Okay, great. Okay, so someone here said, many of the materials referenced are European and likely not certified for use in Canada, and obviously shipping them over here has major carbon impacts. With these products that are ready for use now as substitution, how do you see the certification and development of these as specifiable projects on Ontario projects manufactured here as well?
Okay, Alec, this is a good question, and I'm glad you got to like the very specific level, because these were challenges that BioBuild Collective project wanted to engage with directly. So I guess, first to talk about the fact that they're suggesting materials from different locations. There was kind of a framework that each firm thought about. The most important priority was, can you find materials that are from the Toronto bioregion? And the definition of that is a little bit, like Southern Ontario. We could get more specific around watersheds or whatever. Like, doesn't really matter. Is there something local that it has is a biomaterial? That was the top of the level. The next one priority down was, can you get a biomaterial, but it comes from somewhere else? And obviously you want to minimize the amount of carbon related to get it to the location. And then you start getting into things like, well, is there a material that has more ability to sequester carbon, even if it has some other things in it, or maybe it's just more environmentally benign, maybe it's recycled or reused or whatever. You can sort of go down that list. So definitely firms were thinking about that when they were specifying materials, but all of these projects were thinking about the future. So they were okay with selecting materials that were European, even if there were carbon impacts around transportation, and even if there were challenges with directly using them in Ontario, because it's a way of breaking that chicken and egg thing. You may know the government of Canada has lots of money to sponsor innovation around materials, and it currently actually is doing a survey of where post-agricultural waste can be used in the building industry. Like, what are the resources that we have available? The answer is there are lots. Canada is rich in this kind of biomaterial, but their questions are, before regulations get in place, about readiness. Is there availability? Is the industry ready? And then you go to manufacturers and say, well, so you make this product in Europe, would you consider making it in North America? And they're going to say, well, is there the demand, right? So the demand won't happen without the regulations. Probably the regulations won't be put in place unless there's the supply available. That's a challenging thing to fight through, but architects can do that. And that's actually one of the successes, I think, will be the success of this bio wall assembly project. Is you have 6 architecture firms saying, this is what we want. We can design buildings with these materials. We prefer to buy them locally, and we think that people should establish companies to supply immediately. But there's the demand, right? And even though it's future thinking and hypothetical, imaginary to some extent, it breaks out of that cycle of not feeling like you can move forward because of those obstacles around where products come from and all that kind of stuff. So it's just, we got to push through that.
Okay, great. Thank you. And then a question here, do you have any knowledge from the building supply stores in regards to their intention to sell reclaimed materials and even biomaterials?
Yeah, okay, that's a good question too about supply. One of the outcomes of the Toronto Circularity Network growth was that at the beginning there were lots of questions around timber, for instance. If you reclaim timber from older buildings, can you actually use it? Like selling it, you have to be able to know that someone can use it. And there were things that were brought up like, well, you have to probably, if you take a structural material out of a building, have to be able to certify that that is acceptable for structural use in a new building. And so at the beginning of the conversation, it's like, well, how is that going to be feasible? Like, it's going to cost so much to get an engineer to look at every single piece of wood that comes out of a building. And then just within a couple months, that circle, if you like, was closed, right? We found immediately you bump into people that are like, oh, yeah, we know someone who does that. And actually, it's not as complicated as you might think. And in fact, this is how we used to do it when we were deconstructing buildings 80 to 100 years ago. You would have someone regrade essentially the material coming out of the building, and yeah, we may have lost some of that knowledge, but it can be easily rebuilt. And there are in fact people in the network that already do that, and so that's like a building block to then now being able to sell material. There are some deconstructors in Toronto, like trades that do deconstruction of buildings rather than demolition, and they are able to sell reclaimed material from their shops. And actually, a lot of demolition companies. Here's another thing that a general contractor who is part of the circularity network found out when they started investigating reuse of materials. They realized that their demolition contractors were already reusing the materials. They had already a system in place to extract all the valuable stuff and the really high-end things they would sell to us through a retail store. And then the rest of the stuff, they would figure out the best place to sell it to reclaim the value, like copper, aluminum, for sure, gypsum board. Like there are all of these existing relationships that were just not visible until people started diving into them. So I think this is an interesting question. Like, do you have any knowledge about this? I would say, actually, me as an individual, I have very limited knowledge and I have a whole bunch of assumptions about what's possible and not possible. But you plug into one of these collaborative networks, and all of a sudden, yeah, we can say yes to all of those things. We have the knowledge as a group.
Great. Yeah. And I think that speaks to the importance of collaboration, as you were saying. People are doing this work kind of individually or in silos, or, no one's sure what everyone else is doing. But if there is this collaboration, then we can sort of get everyone on board, which is great.
Yeah.
On that note, you mentioned organizations with Toronto in the title earlier. So I wonder if you
Yes.
could expand a little bit more if there's other organizations in Ontario or even beyond that are doing similar work, or there's possibilities for collaboration with.
Yeah, I was aware in putting together this presentation that we're a community at the OAA that is really the entire province, but there's this like attraction towards Toronto, this bias towards Toronto because of the fact that Toronto is the best city to live in the world. I live in Toronto, but what about other places, right? Like, are there other options going on? I can say what I said earlier, that these networks both started in Toronto partly because they require that person-to-person connection that takes a little bit of time to build experience and trust with people, and that's like it's got to start local. And these both happen to start near the university that I work at, and that's how I know about them and are involved in them. But they can start in other places. And actually, as a matter of fact, the Toronto Circularity Network is talking with folks in Vancouver about establishing a very similar structure around the Vancouver Circularity Network. And also some practitioners, some people at the Carleton University, the Ottawa Circularity Network. If we're going to do those two things, we might as well, like make a playbook for any community who wants to kind of establish a critical mass of people engaged with the issue and start building alignment around it. Those things are very easy to do. So I would say, yeah, there are lots of, it's not Toronto specific, even though there's Toronto in the title of both of these things. The idea with the structures of these collaborative groups is that they are bottom up and can be, and probably should be, replicated in other communities.
Great. Thank you. Um, okay, someone has asked about, Alex, I don't know if you are comfortable sharing your email address for people to get in contact with you if they have further questions afterwards as well. Um,
Yeah, I'd be happy
can
to
you
do that. I
maybe,
don't know if can I type in an answer here?
I think if
No,
you
probably.
type it in the chat and just make sure it's clicked to share with everyone, then they will you will be able to receive
Okay. I
that.
think maybe you might be
Oh,
the only
I
one
can
that
do
can do
that.
that.
Yeah. Oh,
But yeah,
okay. No problem.
my email address is pretty easy. And actually, alex@lukachko.ca is a good way to meet to
Oh,
connect with me.
so Alex, sorry.
I see another, while you're doing that, I see that Alec has asked another good detailed question. Any good LCA or carbon calculation tools and software for small firms that could be easy to implement on low budget small projects? Yeah, one in particular, the BEAM tool. I don't know what it stands for, BEAM, that is supported by Builders for Climate Action, I think is great because it has a good balance of it's relatively easy to use. It is a spreadsheet, so there's a bunch of data entry. It's hard to get away from that when you're trying to weigh the carbon emissions of all your materials. You got to have those quantities, but they've simplified the data because it's all collected in the spreadsheet for a whole bunch of very common construction for certainly residential buildings, but also maybe even small buildings of other occupancy types. And I would say that's a great mix. I know that there are many LCA tools. I think a criticism I would have of most of them is that they're too time consuming to use and the data is too uncertain. Like it's okay to have like 2,000 environmental product declarations in a database, but if you can't get the specific ones that you need for a project, it starts introducing ranges into your calculations that maybe don't help you make decisions, right? So you end up like having a lot of time committed and maybe not the right amount of data. If you're late in the game and you're doing compliance type life cycle assessments where you already know the details and you already know all the material suppliers, those are the tools for you for sure. But if you're a small practice working on small projects, the most critical decisions are going to be upfront type decisions. And so you need tools that I think are relatively straightforward and simple to use, not time consuming or expensive. And that's why I think something like the BEAM calculator would be a good one. I would suggest, though, that this is a transitionary thing for practice. Like we know as practitioners, we tend to design from a palette of materials, and that kind of extends to assemblies as well. That's kind of the comfort zone, is that you know which materials and assemblies you're going to use from building to building. That's where your knowledge is and your comfort level based on experience with using them. Right now, everything's shifting, so it's uncomfortable, but very soon we will kind of lock down, well, here's a bio-based wall assembly that I'm just going to use on every single project. And I don't really need to do many more calculations once I've already established that. And this is the kind of thing that I think, again, connecting with others and pooling that knowledge will help us get to those new normals for standardized assemblies and materials as quickly as possible.
Okay, amazing. Thank you. So it looks like that was the last question in the Q&A, but if you are still typing and you're rushing to get your answer in or question in, please feel free to go ahead. We still have a few minutes left. But I will just begin some closing
Yeah.
announcements. So, of course, a big thank you to Alex again for this excellent presentation and for sharing this really important information with us. I know our members have taken away a lot from this, so thank you very much for that. And of course, thank you to our attendees as well for your engagement throughout, your participation in the polls, and submitting your questions in the Q&A. It's been a great discussion. So hopefully, this presentation sparks more opportunities for collaboration in the future. You can get in contact with Alex. I put that email in the chat. So, or sorry, yeah, in the chat. Hopefully this sparks more discussion on this really important topic. Okay, so again, a few closing announcements for those who are seeking continuing education learning hours. Again, the OAA will record your participation in this webinar on your OAA transcript, so there is no need for individual reporting on your part. We just kindly ask for your patience at this busy time of year as we process and confirm the accreditation of your hours within the next few weeks. Attendees are going to soon receive a copy of the slides from this presentation, as well as a link to a survey to submit your feedback for today's webinar for our presenter. So we at the OAA and our presenters really highly value this feedback. So if you do get a chance, once you receive the link to complete that survey, that would be great. Our next webinar takes place tomorrow, Thursday, May 7th, with the title Low Cost is Low Carbon, Practical Design, Materials, and Policy Handbooks. That's another climate action webinar. So we're really looking forward to that one and hope you can join us for that webinar as well. For a list of all of our upcoming webinar offerings, check out the Continuing Education Webinar Series page on the OAA website. And if you are looking for additional ways to get your Con Ed hours before the end of cycle, be sure to check out the Con Ed Opportunities page as well, where we list continuing education opportunities offered by other organizations beyond the OAA. So with that, I will extend a thank you again to Alex for this wonderful presentation. Thank you all for your attendance today, and I wish you all a pleasant remainder of your day. Thanks very much.